By this point, you've probably worked out just how important shielding gas is in TIG welding, and although we have touched on gas purging and its importance in welding tube and pipe products for motorsport, it's time we took a much more detailed look. In this module, I'm going to show you the effects of purging and why it's an important process. Purging refers to the inclusion of our argon gas from the lower end of our workpiece to push the atmosphere and its harmful contaminants out of the top of the workpiece. I first learned about purging in high school when I worked at a fabrication shop that produced stainless steel tanks for the dairy industry. These huge tanks required TIG welding, and due to the requirements put on food-grade items, they required the welds to seal both on the inside and the outside. It was my job to get inside the tank and distribute the argon to the backside of the weld, whilst the TIG welder did his job on the outside. Fortunately, in motorsport we work with much smaller parts, but the exact same principles apply. We're sealing the backside of the weld to increase performance through flow and decrease the vulnerability of the joint to stop cracks forming from an open weld seam. I have some 1.75 inch diameter 304 stainless steel tubes that I'm going to weld up to demonstrate the process and benefits of purging. The preparation of our material remains the same, but we must pay close attention to the inside of the tube, as the point of purging process is to rid the inside of contaminants in the atmosphere. If we were to leave any oils or debris, it would undermine the entire process we are trying to achieve. After removing any internal burrs, we can use a Scotch-Brite pad to clean and expose the surface of the material, followed by a wipe with some acetone on a rag. These parts are now clean and ready for tack welding. Tack welding before purging will be necessary in 90% of the parts we work with. As motorsport fabricators, our parts are often elaborate structures such as exhausts and intercooler pipes. If we keep our tacks small, the reactive metal won't be affected and our parts can be built and mocked up prior to purging and welding. Once tacked together, we can prepare our parts for purging. Distributing the argon from the bottle into the workpiece is the same process as your welder uses. A flow regulator can be T-pieced into your existing one and is the best way to precisely measure your purging flow rate. No matter what shape your workpiece is, the same principles apply. We need to fill the part with argon and displace as much of the atmosphere from the inside of the pipe as possible. Argon is heavier than oxygen and nitrogen in the atmosphere, so we always fill from the bottom and vent from the top. This can be done a number of ways and gets easier when your weld joins is far enough away from the entry and exit of the tube. If your entry and exit point won't be subjected to the heat of the weld, then it's common for masking tape or aluminium foil to be used on either end of the part. This method can present some problems. Tape leaves residue and if heated can catch on fire. Aluminium foil can also be problematic if heated because it can melt and stick to our part. Issues can also arise from moving our part and dislodging the inlet tube that supplies the argon. These are all the downsides to doing things on a budget, and although the results can be satisfactory, they're not the industry standard, and I'll show you why. There are special purge plugs on the market designed specifically for getting the best results from this process. They're made from heat-resistant silicon and fit specific to their size. And they also have a multi-layer stainless steel gas diffuser designed into them, which works like a gas lens to spread out the argon and improve coverage. Fitting these is simple and they make the process quick and reliable. If there are any holes in the part, then these need to be blocked, and once this process is complete, we can turn on the gas and set our flow rate to between 10 and 15 litres per minute, or 20 to 30 cubic feet per hour. As the argon flows into the part, you should be able to hear and feel the atmospheric gases exiting at the other end. The larger the part, the longer we need to wait for the atmospheric gases to be pushed out by the argon. At 10 litres per minute, we'll fill a volume of 1 litre in just 6 seconds. This isn't an exact science though, and we will have a period of time where there is a mix of gases, and the longer you leave it, the more argon you will have in the part. We leave the argon running at this rate for the duration of the weld. The process of welding stays the same regardless of what's happening on the backside of the weld. For the purpose of this module, I've completed 2 samples so that we can see the differences of purged and non-purged parts side by side. With my 2 samples opened up, you can clearly see the improvements in the purged part and the benefit that this would have in motorsport applications. If this was a single weld in a set of headers, then you can begin to understand the flow improvements that purging will have. We can also see that the dull and porous weld that makes up the backside of the part we failed to purge, there's a good chance that this will present some strength and cracking issues with harmonics, vibrations, and the contaminants contained in motorsports. If you put a lot of time and energy into making a part, then why not finish it off to the best of your ability by applying the purging process? For the price of a small amount of gas, we can complete a weld that will last the test of time and lift your fabrication level up a notch. That was just one module from our practical TIG welding course. If you want to learn more about TIG welding, or you're looking to apply it to your car or motorcycle, then this course will be perfect for you. It will give you a greater understanding of the machines, settings, material preparation, and TIG welding techniques used in motorsport to turn your ideas into a reality. We run you through a 6-step TIG welding guide as well as our material-specific guides that will remove the guesswork out of the TIG welding process. This course is perfect for anyone looking to get into TIG welding and will fast-track you and your projects, saving you time and money in the process. Click the link in the description to get started. Thanks for watching, and remember, if you like that, then let us know by giving us a thumbs up, and also if you haven't already, then subscribe because we'll be coming out with plenty of general fabrication tips and tricks here at ETS Fab.